Hi everyone, I hope you're doing well. I'm Alex and I'm gonna show you in this video how to display data from Firestore using Jetpack Compose. This is a video for an article that I wrote, link is in the description below, which was recently published on the Firebase official publication on Medium. But what is this Jetpack Compose? In short, it's Android's modern toolkit for building native UIs when there is no need for any recycler view adapters, data binding, or even XML files. We'll see in this video how we can keep our code simpler, cleaner, and easier to maintain. Before going forward with the project, please note that in order to be able to use the source code of this application, you'll need to install Android Studio Canary build, which is the one from the right. Besides that, some of the dependencies are still in alpha or beta version. So, if you'll use later versions, you might notice some changes. However, if you are using the exact same version I'm using in my project, the app will work perfectly fine. Now, let me show you how this application works. On the right hand side, I have the Android emulator. So, let me run the application. As you can see, we display a list of product objects that are coming from Firestore. There is also a progress bar that is displayed as long as the async operation for taking the products takes place. Let's also take a look at the project. First of all, let's see the dependencies with which I'm working. So here are the KTX versions for the fragment and the ViewModel. Here are also present Kotlin Coroutines and Firebase Firestore dependencies together with Dagger Hilt. In the build.greater project file, I have added as variables the versions of all dependencies. We are using a very simple structure which contains a data package with two data classes. Because the response from a Firebase Firestore database call can be either the data or an exception, never both, we are using this data or exception class. The second class is the product class, which contains some regular fields like the ID, the name, the price, and the day. However, in this example, for simplicity, we only use the name and the price, which is actually a purely random number. The second package is called DI, which stands for Dependency Injection and holds a single class named App Module. This class provides the query object that will be used to get the data from Firestore. For instance, to query the products collection according to the product name ascending, we'll inject this query object directly into our repositories class construct. The third package is called products and holds the classes responsible for getting the products from the database and displaying them in the UI using Jetpack Compose, but we'll get back in a few moments. The last package is called utils and holds only an interface with two constants, the collection name and the name proper. For using Dagger Hilt, it's mandatory to have a class that extends application. This class should be annotated with Hilt Android app and added in the Android manifest file as well. Now let me close all these windows and get back to our products package and let's open products activity. This activity is annotated with Android entry point, so we can tell Dagger where to start. Something to note in this activity is that we can directly use a ViewModel object as it's already provided by the ViewModels. Before diving right into the code that is related to Jetpack Compose, let's open again the repository class. Because we are using Kotlin Coroutines, we can define the getProductsFromFirestore function as a suspend function. And inside the try block, we can call get on the query object and then simply call await. What we get in response is a list of document snapshot objects. But hold on, we need a list of product objects. In this case, we need to map each document snapshot object into a product object using document snapshot toObject function. Once we get the data, we can store it in the data object, which is a generic property that exists inside the data or exception class. If we get an exception, then we need to set the E property in the catch block with the corresponding Firebase Firestore exception. But remember, we can get one or the other, but never both. In the end, we simply return the data or exception object. Now it's time to propagate the result that we get from Firestore further in the UI. So it's time to open again our ViewModel class. In this class, we'll have to define two mutable state objects. The first one is called loading, and it's a mutable state of type Boolean. We'll observe its value to know whether we need to display the progress bar or not. The second one is called data, and it's a mutable state of type data or exception. We'll observe its value to know the moment when we receive a response from Firestore. This object is created by passing to the mutable state of function a new instance of data or exception that contains an empty list and an exception with an empty error message. Once we get the response from Firestore, we'll be able to populate one or the other property with the corresponding data. This example uses ViewModel scope that is provided by the Lifecycles ViewModel KTS artifact that exists inside our build.gradle module file as seen earlier. Inside the coroutine scope, the first thing to do is to display the progress bar, and as soon as we get the data or the exception, we hide it. Now let's get to the UI part and see how to build the row view for each product object. Let's open again the activity class, where we can see that this can be done by creating a lazy column and assign a product object for each and every view. I chose to display each item in a card view, so let me show you how it looks like. It has a really simple layout. It contains only a row that contains in terms two texts. The first one is the product name and occupies 85% of the width with the start alignment, while the second one is the price, which is aligned to the end. Back to the activity, you can see that if something goes wrong, in the case of an exception, we set the error message to a text. The last thing is the circular progress bar, which is displayed as long as the async operation for getting the products from Firestore takes place. Let me open it. Inside the constructor, we have a boolean called isDisplayed, and according to it, we display or hide the circular progress indicator. That's almost all of it when it comes to getting data from Firestore and display it in the UI using Jetpack Compose. So, working with Jetpack Compose for creating the UIs turned out to be much easier than traditional ways of dealing with the UI elements. So, Android team, you really did a great job. So, in the end, guys, if you enjoyed this video, please hit the like button, and if you think you learned something new, please subscribe to my channel as more videos are coming. Bye!